Hello everyone, thank you so much for coming. My name is Julie, I'm an interaction designer at Google. I'm here today with my colleague Rafal, who is a software engineer, and we both work on Google Kubernetes engine. Today we're going to talk about our approach for faster and more reliable deployment and release process. This is designed to streamline developers and operators' workflow by integrating some of the most frequently used tools available. During this talk, we're going to explore the problem space, commonly adopted industry tools, and our proposed solution with a demo. Now, there are many tasks in the product development cycle. Let's go over some of the core ones. For developers, this includes writing and testing code, improving the observability for the system, and so you can improving monitoring and telemetry. For operators, this includes testing applications in different environments, monitoring the health and security of the application, and implementing necessary upgrades and updates. Please note, depends on the structure of your organization. These tasks may be performed by one or multiple engineers. And for this presentation, let's assume these tasks are for developers and operator roles. So now let's look at where these tasks are performed in a general development and release workflow. First, developers write codes in their local environment, have it reviewed and committed to the version control repository. Next, they request the deployment and testing environment and hand it over to the operators. Operators then decide what is to be deployed and where to deploy it to. Then they build the deployment and publish the artifact, after which they modify the Kubernetes resource manifest and apply the changes to the test environment. Once deployment is done, operators will notify the developers. And developers then verify the deployment, perform manual testing, and correct any errors in their code, configurations, and deployment specifications. After a release is ready, developers request a deployment to production, then hand it back to the operators. Operators then repeat the process as deploying to the testing environment. They decide what is to deploy and where to deploy it to, and then build and publish the artifacts, and finally deploy all the artifacts to the production environment. This is both a laborious and tedious process. As you can see, all the core tasks are only a very small percentage of the entire flow, which got us thinking, can we automate some of these steps so that developers and operators can focus on what they know best? Now I'm going to hand it over to Rafal, who is going to talk about our proposed solution.
Thanks, Zhuying. Okay. So Julie described the workflow and noted that it could be simplified, but how can we do that? The cloud-native ecosystem is pretty complex, as you can see, and for most problems, there's more than one tool that you could use to solve it. The solution we would like to describe today relies on tools that you should be familiar with, or even use in your daily workflow. So it should be possible for you to easily and gradually adopt it. We'll show you how you can use version control systems to manage your deployments and be the source of truth for deployment state, how to use CI/CD tools to reduce the number of manual steps, and we'll introduce a new tool, OSS Cluster Registry, that can help you manage the mapping between applications, stages, and clusters in a similar declarative way. I'll be using Git in the demo later today, but the general pattern works with any other version control system. We'll use it for storage for application code and configuration, which should be familiar, and also for Kubernetes manifest, the files you use to deploy your app. I don't want to get into the single versus multiple repos discussion here, so we'll assume applications have their own repos, but we'll have a shared info repo for manifests. Then we'll use a CI/CD tool. So there are many of those with various degrees of integration with Kubernetes. But the features I'll assume today are being like the possibility to define a custom task, things bash script, and a possibility to trigger tasks from a Git commit, which all of those tools should provide. Okay, and now I have a question. So how many of you use more than one Kubernetes cluster in your day-to-day work? Okay, a few. And how many of you are familiar with Cluster Registry? Let's do. Okay, thanks. So I'll introduce. So Cluster Registry is a Kubernetes open source project. It's basically a Kubernetes custom resource that you can install and use to track to the list of the clusters you're interested in. It stores information about the cluster itself, the API server address, certificates, and has all the standard Kubernetes metadata. So you can use labels to query and filter the cluster you're interested in. It also lets you define custom operators and controllers, but we'll not talk about this here. So Cluster Registry helps us do a few things. One is we don't need to know the mapping between application environments and clusters by heart, read the docs, or try to infer it from other sources. We can rely on Cluster Registry storing it. Another is that the Cluster Registry is the source of truth that lets operators make changes to environments without the need to update individual app config files or inform developers. Imagine from tomorrow you have to run your prod apps onto clusters, or you want to replace the test cluster with a new version. How many things would you have to change in your current code? So let's look at the workflow Julie presented before. I highlighted some of the steps that could be automated or could benefit from integration with the tools I mentioned. First, you can trigger many of those steps with Git commits, be it pushes, like standard pushes, merges, or pull requests, whichever workflow you use. After which you run a predefined task in the CI/CD pool. Deciding what to deploy and where can be simplified by first following a convention that maps the source code versions to artifact versions, and by using Cluster Registry. In my demo, I'll use Git hashes to tag my artifacts, but any versioning scheme works as long as you can maintain the relation between source and artifact. Builds can then happen automatically, as you imagine, and the deployments are triggered by commits to the infra repo. I'll show this in details later. Now, Cluster Registry can also help us in a few things. So first, it tells us what to deploy and where, like if we have a version, which clusters to deploy to, and then we can get the details of the clusters that we require to do the actual deploy. And then there's one more step we included, but you shouldn't be doing this. So if you want to follow immutable deployments, which are a good idea, you shouldn't be rebuilding your app between deployments to different stages. So after those stages are automated, there's much less manual work happening. So you can focus on improving your application and improving your infrastructure. So this is the simplified workflow. And now let me try to switch to the other screen so I can show you the demo. Is it visible? Do you need the fonts to be larger? Larger? Okay. So yeah, I have more than one, so sorry. Yeah, fine. So I prepared a quick demo to show you how to combine the tools and conventions mentioned before to optimize your deployment and development workflow. I wanted to make sure that the demo works without connectivity to the cloud. So all the things I'll show you run locally, and I will use a single cluster with namespace environment, 3 local Git repos, and I'll do the CI/CD steps locally using a makefile. So we will take a look at a simple microblogging application that lets you post short messages. The app has 2 components: a front end that shows the list of messages in HTML, and a back end that provides the storage and query API. Both run in Kubernetes and share 3 main stages of the development pipeline. So we'll have a local environment when we build from code. We'll build the code and run it. And then staging and prod, which use pre-built and pre-built Docker containers pushed to a container registry. Each component lives its own Git repo, as in here. So we have backend is one thing, front end is the other thing, and then we have an infra repo that contains all the manifests. Let's take a look at the app in the local environment. So I'll just quickly build it. And it's up. So this is the backend, so just a list of messages. And the front end. Okay. And as you see, I included a text that identifies the environment, and also the sidebar will change colors. So when we go to staging, things will change. So it's clear which environment I'm using. Okay, so let's go through a simple change workflow. So we'll add a feature where we show the timestamp, the time that has elapsed since the message was created. So our backend team already did that, and they include the timestamp. I want to make it to change the front end to include the message like that in this screenshot. So I'll make the change locally. As you see, I just added a simple text and map the data I get from the backend. And let me try and run it to see if it works. Okay, everything is refreshed, and we see the timestamp. Let's see if it works for new messages. It does. Okay, so now I'm ready to commit my changes and run through the deployment workflow. So git commit. And now I'll have to be the CI/CD tool since this is all offline. So let's pretend that all commands that start with CI are run on a CI/CD tool. So first we built the artifact. So I built the Docker image and pushed it to the registry. And then we trigger the staging deployment. So I find the version that needs to be applied, reconfigure the staging cluster, and wait for the version to be rolled out. And I go to staging, and let's see, this works. Yeah, as expected. Let's try adding a message. Fine. Okay, so sounds like we should be ready to deploy the version to prod. So let's wait for all the replicas to be updated. I switch to prod, and what happens is that we have an error. Like something is wrong. I'm not an operator now, so I'm not trying to debug the thing in production. I'll do the first reasonable thing. So I'll just roll back the deployment, and we'll try to fix everything later. Roll back. How do I roll back? How do I know what to deploy now? It's actually easy because we have an infra repo that stores all the things that happened to all environments. So if we look at the log, I updated the staging to the new version, then I updated prod to the new version, and then I just did a git revert command and applied the manifest. And now I'm at the previous production version that was known to work. Okay, so for now, prod is back up. And this shows you how the proposed workflow could work. And as you see, it could be automated, but I'm running it locally, so I had to do the things myself. So what can we do now? Before we mentioned that automating your workflow will save you time, and you can spend that time improving other aspects of your product. So as you know, it's critical that your production is free of errors. So how can we try to deploy a new version of the app and test it in production while minimizing the impact of the bugs, so that less people see the bugs? And one of the methods of solving this problem is called Canarying, where you deploy the new version to a small subset of production servers, verify the impact of the change, whether it's metrics, manual testing, or other signal you can use to see if the new version is working, and then we decide whether to proceed with the rollout to all servers or to roll back. And this should be, especially if your rollouts take longer than what I showed here, this saves you valuable time when everything is broken. So let's try adding a canary to our workflow. I'll just add a new environment. I just need to add a new folder to the existing infra repo without modifying the app in any way. Sorry, git status. I have a new file. It's very similar to the product. Oh, sorry, I didn't try that. That should be better. Yeah, it's really similar to what I have for prod or anything. I just configured my prod service to send some requests to Canary. And now I'll commit the change to the infra repo and try rolling out to Canary. Like CI. So again, we'll try to promote a known wrong version from staging to Canary. But at least you should know, see how this works in production, how a rollout of a new version that might be broken works. So as we see that prod is fine. Most of the requests will get prod, so they will be fine. But the requests that hit the Canary are still broken. Okay, let's kill the Canary. And there's not much more that we can do as an operator. We just need to let the developers figure this out. So now, assume I'm a developer that comes back to the office after a conference. And I learned that there was a terrible bug that happened, and I don't really know what was the state of the environment and what happened. So how do I now reproduce the bug in my local environment? Because that's where I'm the most effective. With our workflow, that's easy. All the changes, even the ones that happened after we did what we did here, are recorded in the infra repo. So I can see that there was a reverted commit. This is the one that was reverted. I can use that to find the exact versions of different components that were running when the issue was triggered. So this is the backend version. And now the front-end version. And this one. Oops. Oh, sorry, bad copy. Okay. Now we can run locally using any tools you're familiar with, and should be easy to reproduce this and see what happens. Okay, we see the error. Let's check out what happens with the backend. Okay, so it looks like the backend team didn't deploy the change that they prepared to their prod environment. And it's still not there now. So we can either wait for them to stop all releases of the front end until they release, or we can fix this on our end to support both versions of the backend. Let's do the second thing. So I'll just stop here. I'll apply a simple fix. So we just add some ifs to make sure that we don't throw an error, but handle this gracefully. And does this fix work? Backend is still not returning the date we have, but the front end works, so it looks good. Will it work with the new backend? So let's get the last version they have. Okay, looks like it works. The backend returns the date. We don't see the, sorry. Oh yeah, we're refreshing. So we should see the date. Maybe let me hard reset. Okay, now both components were updated, so my code from my local environment works with both old and new versions, so we're safe to deploy forward. I'll make a new branch. Sorry. Okay. Commit. You probably should get your changes approved, but I'll just merge to master and trigger the deployment workflow. So again, our old workflow, this still works. Our old workflow still applies, so we build the change. push to Canary, push to staging, sorry. Rolled out. Let's look at staging. This worked. Now Canary, CI. Sorry, trying to be. Whoops. Oh, okay. Yeah. We need to revert to the right version of the info repo because I checked it out before. Now. So those problems wouldn't be there if you properly pushed your changes to some upstream, but I'm just doing everything locally. And now we see that prod works, and Canary also works, but the backend is still not updated. So let's pretend that our friendly backend team deployed their changes, and we can safely check if the Canary now should work while in display the dates, while the prod will not work, and not, I mean, will still work, but not display the date. So make prod up. Backend was configured, so prod version doesn't work. Canary shows the dates. Okay, so it looks like we're good. We can proceed with the rollout. So prod. One replica, two replica. Get rid of the old ones. Okay, both prod and Canary, come on, Canary have the new version of the code. So, as you see, I hope you found it useful, and you were able to follow along because I probably did that a bit too quickly. But as you see, the structure we proposed allowed us to automate some repeatable tasks, moving from static environment mapping to declarative, easy-to-change tools. It also allowed the operator to add a new deployment step without changing the app in any way. The operators can change the infrastructure and the infra repo, and the developers don't have to make any changes to the application code. And finally, it also made it much simpler for developers to reproduce issues caused by mismatched state in a remote environment, which is usually quite tricky. So now I'll let Julie summarize. First I need to fix the slides. Okay. I don't know where it is. Let me open a new one. Sorry for this. Can we do that? Yeah, we have that here. Sorry about that. Okay.
Okay. Thank you so much, Rafal, for the demo. The new workflow really helped us to automate some of the very tedious work and let both roles experiment what they do without impacting one another. As you can see, in the old workflow, developer has 5 steps to do with 4 steps as their core tasks, and operators has 7 steps with only 1 step that is their core tasks, which was what we mentioned in the second slide. And in our proposed solution, however, we have automated the workflow, so the developers and operators only need to worry about the core tasks. Thank you, everyone, for coming. It's been a pleasure to talk with all of you, and we hope this presentation is useful for your work. And we're happy to answer some questions.
So one question in your demo, you set the repository tag image tag with the same ID of the commit tag. So how do you do that? How do you make it happen?
So when I build the Docker image, I just look at the Git commit I build it from, and I Docker tag the image. I'm just using this for simplicity. You could follow a versioning scheme, like you can use pretty much any scheme. For as long as for example, you can, if you want to do something else as your artifact version, you can tag your Git commits with the version you assign. So if you say this version will be 1.1.1, you just tag your Git repo with this version, and then you can look it up.
Okay, so you have some scripts at the backend to do that.
I can share the makefile I used to do this. It's basically get the revision at head, cut it, and tag the Docker build to this.
Okay.
Yeah.
Thank you.
You're welcome.
Anyone else?
我的问题是这样子，就是你的服务都是以 deployment 的方式来部署的嘛？但我期望有一些服务，比如说像数据库啊，它需要固定一些资源，比如说它的挂卷和它的 AP 需要是固定到某些节点上。所以说我们在 K8s 里面会使用 stateful set 来进行部署。但我们 stateful set 在进行发版的时候，它总是有一个顺序的，就是说如果我先发一个新版本的话，我要先把旧版本给卸下掉。但是它顺序是一个逆序的过程，所以我希望它的那个服务的流量切换是一个正常的过程。你们是怎么样解决这个问题的？
I'm sorry, I don't fully understand your question. Sorry. Okay. Anyone else have any questions?
Hi, in your daemon, I see when you type the CLI command, it builds a Docker image, right?
Mm-hmm.
So I want to know if the Docker image is built locally or remotely, and some Docker image might be, the build process might be quite slow. So
yeah,
do you have any?
Oh, sorry. Yeah, of course. So again, I wanted to make sure this works locally. So in here, I build it locally, but you could imagine that the CI build step is run on we have a Google Cloud Builder. There's a number of tools that build your Docker images remotely. So this could work there. And then when the process is done, you can trigger the next step. So I would assume you build them remotely, not locally. At least the Docker images that you want to push to staging or production. Does that answer your question?
Yeah, thank you.
Okay.
Anyone else have any questions?
So I think, thank you very much for coming, and I hope you enjoyed the presentation. Thanks.